Hey guys, welcome back. We're going to talk about the common ion effect in this video. All right. So in an aqueous solution, all right, if we're going to call common ion, the common ion is added to the system or the solution, then the system will move away from that ion to restore equilibrium. The system will move away from that ion to restore equilibrium. All right, this is Le Chatelier's principle, of course. All right, so if we dive into an example here, if we had a weak acid, let's just say, example, hydrofluoric acid, easy to write. So we have hydrofluoric acid in water, and then we have hydronium and fluoride. All right? Okay. So one, all right, if, let's just say some sodium fluoride is added to the same container. So what do I mean by this? I have a container, let's call it a beaker. And in here we have our HF and F minus and H3O plus, right? If we throw in NaF, and it's a strong electrolyte, I'm going to get Na plus and then F minus as well, right? And so NaF solid, Na plus, and F minus. Common ion right there. So we have two fluorides, all right? That's the common ion. Well, that means that the fluoride ion is the common ion. All right? Which means in this situation, our equilibrium will shift to the left. Right? So 2, our equilibrium shifts left. Right, it's going to shift left because F minus is the common ion. And then when the addition of the common ion suppresses the ionization of the weak electrolyte. All right? Because if you look at HF, that's weak. And sodium fluoride is strong, right? Strong electrolyte versus weak electrolyte. So the common ion, right, always suppresses the ionization of the weak electrolyte. Another one, for example, let's say you had silver. Well, what do we want to do with that? I don't want to do that one. HCN, another weak acid. plus H2O liquid. Then you'd have hydronium, and you'd have cyanide. And then you could add potassium cyanide, all right, and you have your common ion here. Well, which one's weak? All right, potassium cyanide, strong electrolyte, it's going to separate until it reaches its solubility limit, where the weak acid will be suppressed. So HCN, right, the top reaction, right, cyanide and hydronium will meet up and shift the reaction back to the reactants to make more hydrocyanic acid. All right, so that's what the common ion effect is, and it affects equilibriums and it affects the ionization of the weak electrolyte. So that's the big point. That's the big takeaway, is that the common ion suppresses the ionization or dissociation of the weak electrolyte. Hopefully that works for you. If you have any questions, reach out. Otherwise, we'll see you next time, guys. Take care.